It's Peter from DevMentors, and welcome to the third episode of building our simple microservices-based app called the FeedR. Within this episode, what we are going to talk about is the API gateway. And there might be a variety of reasons why you would like to actually add some kind of a gateway, or maybe just a plain, simple reverse proxy into your solution. So let's say one of the core benefits and one of the, let's say, main reasons why you would like to have a gateway within your microservices based app like we have here within our solution is that essentially what you would like to provide is some kind of a public facade on top of your system. So when you think about the consumers of your, let's say, microservices, you don't really want them to be aware, let's say, that you have 10 or 1,000 or 500 of different microservices. You don't want them to be aware where these microservices live, what are their IP addresses, DNSs, how should they authenticate to these microservices, what transportation layer should they use, and so on and so on. So this is one of the core reasons why you might want to have the gateway in the first place. So expose, for example, this single endpoint. And of course, you might think of, for example, having multiple different gateways. Let's say one gateway for the web apps, one gateway with different endpoints, different data for the mobile apps, another one for desktop apps. But in our sample, let's just focus on a single gateway. So we'll have this single entry point, and this will be responsible for, at first, properly routing the consumer of our microservices based solution to the actual services, so that the end consumer of our API will not care what are the services, how many of services are there, which instance of the particular service will, for example, handle this request, what transportation layer is being used internally. All right, so for example, our public API consumer might talk to us through the HTTP, but internally, theirs might be, for example, using some WebSockets, SignalR, gRPC, or anything else. The same would apply, for example, for the authentication, authorization. Maybe you like to add some request headers, maybe some correlation IDs to our headers sent by the gateway to the microservices. So there is, let's say, multiple reasons, not to mention things like load balancing, session affinity, and many, many others. So today, within this episode, we are going to talk about the gateway, and actually we are going to implement the gateway. And to add gateway into our already existing solution, we are going to use a very nice library built by the Microsoft, which is, let's say, the official Microsoft Reverse Proxy that you can find publicly on GitHub, and the YARP, as an acronym, stands for Yet Another Reverse Proxy. Also in the past, I did use in at least a few projects the Oslo Gateway, which I think is still probably the most popular API gateway written in .NET, but I'm not really certain, at least at the time of recording this video, what is the status of this project. So I can't recommend it whether you should use Oslo or not, even though I really like this project. Also in the past, just to, let's say, get a better understanding of how the gateways are being built, I also built my own gateway called Entrada, so you can check out this code just to see how you can also think of building your own gateway, how this reverse proxy mechanism works, and how you can apply some additional extensions to it. But in this episode, we are going to take a look at the YARP, which by default stands for a simple reverse proxy, but it's really nice and mature library that have been used, at least what some of the articles are telling us internally within the Microsoft. Some of them teams, some of their divisions, and they just decided to make it public, which is actually great, because on top of this very well established, very fast reverse proxy, you can build your own proper API gateway. And since this is actually just an ASP.NET Core middleware, quite advanced, but still ASP.NET Core extension, to put it in these words, you can do pretty much anything with it. And there is like lots of built-in features into it. As you can see in the docs, there is authentication, load balancing, there is request transformation, data aggregation, lots of stuff, even things like health checking, gRPC, so a lot of stuff. And when I first used this quite some time ago, there were maybe like a few sections within this articles, right, page. Now there is like dozens of them, so that's really cool. And I can see that they really put a lot of effort to make it very good and usable reverse proxy. And I've been using it for quite some time now, and I'm also very happy to say and to hear from their side that they finally released the production-ready version 1.0 quite recently. So let's now jump into the code and let's see how we can make use of the YARP and some of its basic features. Let's see how we can use YARP, all right? So if you just type something like yarp.net, you will find this link that will redirect you to this official reverse proxy for the YARP, this documentation website. And under the articles, you'll actually find a lot of nice sample articles with code that you can use to start working with the YARP. So let's jump into our code and let's expand our gateway project. And we are simply going to install this reverse proxy. All right, so here we are going to install this YARP reverse proxy, this NuGet package. And then we are going to add very easily the YARP into our project. So we can do something like builder and then services. And then you will find here this extension called add reverse proxy. And now we want to load the configuration from the file. So by using load from config extension, we are just going to take our configuration object from the builder instance, and then let's say we'll keep our configuration under the section called YARP. All right. So this is going to add the required YARP components to our IOC container and register all the required services. And now here, let's just call app and then map reverse proxy. So we can actually provide there some specialized kind of endpoints and middleware to allow the YARP to redirect our request to the provided endpoints, for example, based on the configuration file. Now let's move into our app settings.json, and here what we want to do is to provide this YARP section. So let's start with the YARP as our section name, and we want to start with the routes definition. So here let's just start adding the routes one by one. So since our gateway is going to be the only public facade, right? Our only, let's say, public API that should be used by the end user consumers of our system. We are, of course, not going to expose the gateway within the gateway. We'll just expose the aggregator, the notifier service, and the other 3 remaining feeds microservices. So let's start, for example, with the aggregator service. So here I'll just say something like, I want to have the route living under this aggregator unique name as the key within this JSON object within this dictionary. And then at first I will say, this is going to some kind of a cluster ID. So the cluster will be actually responsible for containing the URLs, the destinations, so-called destinations of our services. So I'm just going to call my cluster ID just aggregator, the same, let's say, as my key here. It doesn't matter, just to be consistent and come up with some appropriate convention when it comes to naming your, for example, YARP endpoints definitions. And now what I'm going to do is something like, so I want to have this match. So the match, if you take a look, and for example, within this YARP documentation and at the section like how you can actually make this routing within your services. So here you will find this, for example, match, and then you can just provide some kind of a path, also including some additional wildcards like this, for example, catch all wildcard. So let's see. So what we want to do is something like, so when someone sends a request to our gateway URL, which is localhost 5000 for now, and let's say provides this additional aggregator as within the endpoint, within the public endpoint, we want to route it, for example, to our aggregator microservice. So here, I'm just going to provide some kind of additional wildcard. So whatever will be sent under the gateway/aggregator, and then pretty much any kind of additional endpoint or query string, I just want to forward this further to our aggregator service. So here I'm going to say, I want to catch anything that is part of this endpoint or query string, whatever there is. And then this is going to be our path. So let me just do it like this. So the path of this for this match will be this endpoint, this kind of, let's say query. And then we want to provide here so-called transformation. And the transform, as you can see here, so you can transform a lot of stuff. For example, you can provide here some custom HTTP request header transformation, or like in our case, some kind of path transformation. So what we want to do is to redirect this to our aggregator service, but we want to only pass further. We only want to provide this catch-all endpoint query string, whatever there is. We only want to send this further. We don't want to call our aggregator with additional aggregator endpoint at the very beginning, right? Because it wouldn't make sense. So we want to use this path only to say, this is this path, this is the part of the gateway pointing to the aggregator microservice, and then to our aggregator microservice, we only want to provide, which actually makes only sense, which makes sense, only this part, right? So whatever the endpoint, whatever the query string is, without adding additional to our part and to our path, this aggregator part. So let me just provide here, according to the docs, this transforms, and then within this dictionary, we are just going to provide this so-called, as you can see here, path transformation pattern. So I'm going to put there the path pattern, and then I'm going to provide here, well, that's the only part of my path that I'm interested in. So I don't care about this one. I am only interested about this one. So this is what I want to transform. This is what I want to pass further into our service. Now let's jump down here, and under our routes, what we want to do, we want to provide, well, as you can imagine, we like to provide here this kind of cluster definition. So where our microservice actually lives. So here, let's just declare the cluster section within this YARP configuration, still within the same section, our root section of the YARP config. And then I'm just going to provide for our key, the first key, which is the aggregator. This is our cluster ID with the key aggregator. So this is going to be my first cluster. And then I'm just going to provide the destination. So here, according to the documentation, once again, there will be my destination, and I can, let's say, for example, call it destination 1. Doesn't matter where I call it. And then the address for my destination is going to be, well, the actual address of our aggregator microservice. So for now, our aggregator lives under this localhost 5010 port. So this is going to be the URL, right? So now let's try to run our gateway, and let's see if this is going to work. So if I do, for example, gateway run, all right, we should be able to see that the gateway, of course, works. So let's see, 5000 should redirect us to the gateway. But if I try to do something like /aggregator, let's see what happens. I'm getting 502, which makes sense because, as you can see in the logs, the gateway tried to redirect this request kind of to our 5010, right? As you can see, there is this proxying to and this service URL, but our aggregator, of course, is not working yet. It's currently offline. So it makes sense. So let's run our aggregator now, and we should see that our gateway, when we reach this aggregator endpoint once again, so the service is running, and now we can refresh it, and the data, the response is here. All right, so whatever will be put there further, let's say aggregator, and let's say, for example, ABC, this is going to give us not found, because now we, as you can see in the logs, we try to reach our aggregator and then ABC endpoint, and of course here we don't have any path like that declared. But if I were, for example, to add this path here, let's say if I were to extend my API of the aggregator service with something like ABC endpoint, and let's say hello from ABC, now let's run this aggregator once again. And of course, this is going to work now because I have this one more endpoint here, right? So we have this, let's say, one-to-one routing, redirecting, proxying request from the gateway to our microservices. So the very basic usage of the YARP, just to expose only the endpoints, only the paths that we want to, by using some custom conventions, for example, for different services name, or maybe different modules, different versioning, different kind of wildcard patterns. So a lot of stuff that you can do related to path definition, header routing, header request headers, transformation, and so on. So for now, let me just quickly add here the remaining services. I'll just copy and paste them from the existing config file. Let's see how this is going to work with all services being available. And now let's talk about another cool feature of the YARP. All right, so this is like a whole config for our overall system. So we just have here all the services in place. The aggregator, right? Notifier, 3 remaining data feeds with the unique name as the key within the dictionary, with the path pointing to different services, with the same path pattern transform, and of course with the different set of cluster identifiers. So now we could run our services, we could run all the services and the gateway, so 6 apps in total, and we can just, one by one start hitting our endpoints just as declared here. So let's take a look. Okay, so it's all up and running. And now I can do, of course, we can reach our gateway, and there is the aggregator, right? The first endpoint. There is the notifier. There are our feeds. So let's say the news feed, the quotes feed, and finally the weather feed, right? So that's very cool. We have now a single app which we could expose to our API consumer from the outside world. And then we don't care, the consumer doesn't care how many services are there, but of course, internally we might have a monolith, modular monolith, bunch of microservices. The end consumer doesn't and shouldn't really care. So that's really cool. Now, before we move on, keep in mind that of course we need to provide the appropriate Docker settings for our gateway. So here, for our apps.json, I'm just going to provide here a new docker.json, because when we build our Docker image for this gateway, and we are using this Docker environment variable here, which will try to load these Docker settings, of course, from the Docker, let's say, compose perspective or container perspective, if we will try to run this service internally, for example, by using this already existing Docker compose file within this internal Docker feeder network, we can't really use localhost there, right? Because this will be a bunch of distinct containers. So they can talk to each other by using these aliases, right? These specific names. So for example, if we were now to jump back into our Docker config, so I can just simply do the following. I'm just going to leave the routes, right? So I'm not going to override the routes. They are fine. But instead, we can override the clusters. So I'm just going to change this from the actual hard-coded URLs to something like the names of our services based on our Docker compose file here. So we have the aggregator, we have the notifier for this guy, and then we have the 3 remaining feeds. So there will be feeds for the news, this one, and then there will be the quotes feed, this one, and finally the weather feed, this one. So now we have the proper app settings.json file for Docker usage, and this will make our YARP, our reverse proxy, our API gateway, it will make it work within the Docker containers, Docker network as well. So now let's take a look at additional feature, which is called the load balancing, right? And of course, there is more to load balancing than just setting up the gateway, because there are also, let's say, challenges like service registry, service discovery, some additional load balancing algorithms that you might want to use. So there are, let's say, depending on what you are going to use within your production environment, you might just stick to some hard-coded URLs, or maybe you might decide to go with Kubernetes and then use their service abstraction, or maybe you might want to use tools like Consul, Fabio, Traffic, or other service registry discovery or load balancers to make it work. But let's just take a look at how the YARP could help us with the load balancing, right? So imagine the following scenario. Let's say that we are going to run our aggregator. So I'm going to just navigate to our aggregator service here. And I'm just going to run this service under 3 different instances, right? So I'll just run the first instance, and then I'm going to run the next instance, and I'm just going to provide there these URLs. So for example, I want to run the second instance independently from the first instance, of course. So the first one runs at 5010, the second will run at 5011, and the third one instance of this aggregator service will run under 5012. So we have 3, let's say we scaled out horizontally through our console on the local host. We scaled out horizontally our aggregator microservice into 3 independent instances, right? So we can now reach 5010, 11, and 12. But of course, if we will try to hit our aggregator through the gateway, so if we run the gateway now, let me just run it maybe also for the console so we can see the logs a bit better. Let me just navigate here and let's just run the gateway. You will notice that the gateway will keep on hitting the first instance all the time. So if we now refresh it, and let's take a look, I'm just going to refresh, hit this request multiple times. But if we take a look into the logs, you can see it's always forwarding, it's always proxying to the same 5010, which of course makes sense because we didn't really declare anywhere within the gateway that we want to use any kind of load balancing, right? So here within our gateway, let's see, we are just pointing to the same single instance of our service. So what if we would like to point to different instances? So now let's do something simple. I'm just going to provide here, let's say destination 2, 5011, and then destination 3, which is going to be 5012. All right, so let me just run it. Okay, and now let's see what happens. So if we reach it multiple times, let's take a look. Now it seems to be working. So we have multiple instances, and depending on some built-in algorithm, for example, once it's being sent here to the first instance, then the second instance, then to the third instance of our service. So some load balancing is already in place. And as you can see, by default, it will use this power of 2 as the default choice for load balancing algorithm. But if you want to change it, we can do this quite easily. So for example, we can change this to round robin. So let's take a look. I'm just going to put it there. And let's see if this is going to work. So let me restart. And now if we take a look, let's just run it multiple times once again. So maybe to visualize it a bit better, what I'm going to do is to just return some kind of unique ID. So within our aggregator service, let's just do the following. I'm going to do something like our ID, which is going to be the new GUID, right? And then I'll just return it here within this hello world message. So the ID will be something like this. Okay, so now let's run these instances once again. So the first one, .NET Run, and then the second one with the URLs 5011, and then the third one with the same URLs 5012. All right, and then of course the gateway. So let's take a look how the round robin is going to behave like. And there is the first instance, second, third. First instance, second, third. So you can see it's running as expected. We have a basic round robin load balancing in place, and we are reaching 3 instances one by one. So the first one, second, third, first one, second, third, and so on and so on. So quite easy stuff to achieve some basic load balancing with the YARP. But of course, there is much more than that, because what we've just seen is pretty much just a tip of an iceberg. So let me show you one additional feature that I really like about the YARP. So I'm just going to remove this ID. Let's jump back into our gateway project. And now I can do something like the transformation. So as you can see in the docs, we can do some kind of internal transformations here. So if you take a look for the transforms, you can transform, for example, based on your configuration file. But what if we would like to do some kind of a transform, for example, for our request headers, which is more than just adding some static value for the request header like this, right? So what if I would like to maybe, for example, use some dynamic header with some dynamically generated value, for example, some kind of request identifier, correlation ID, which might be especially helpful when we like to correlate some of our requests, starting from the gateway and then coming through distinct microservices within the synchronous or asynchronous communication. So here, what I will do is something like add transforms, and then here, let me just do the following. So the transforms, and then I'm going to call, as you can see, we have a bunch of extension methods for example, request header transforms, request transforms, response header transforms, and so on. So I'm just going to call this kind of flexible add request transform like this. And then within this request transform, let's just call this one a transform for the specific request. I'm going to, well, as you can see, a bunch of properties that I can actually transform: my path, my query, and so on, my context. I can access the context here because still the YARP is running within our ASP.NET Core. So you can access the HP context and you can do pretty much anything you want, even including the request body. So I'm just going to call this proxy request and then headers. And let's say whenever I hit this, I want to provide some custom header here. So I'm just going to call this something like request ID. Let's just once again generate our unique value for the specific request by calling GUID new GUID to string. And then I'm going to call this add, and let's just provide here some custom header, like for example, X request ID. And let's see what is going to happen now. And I'm just going to return this value task, completed task, because I'm not doing anything asynchronous here. So I don't need to await anything. So let's take a look. I'm going to run this gateway in debug mode now. All right, so let's run in debug. All right, so let's jump into our aggregator now. And here, let's say I would like to somehow pull this custom request header. So let me just pass here the HP context. All right, so internally, I'm just going to call something like, for example, response, write async, and our herald message, right? So it's still working, it's still returning some data, but internally I'm going to do something like a request ID, and then let me take my request object and then the headers, and from headers I will try to use this X request ID as the header name. So let's put it there and let's see if we are going to see any data in here. Let me just actually write it into our response as well. So let me run this aggregator service also in debug mode. Okay. And let's take a look. All right, so let me now jump into aggregator. And of course, we need to actually remove our load balancer settings. So since I'm running only single app now for the aggregator service, I have to remove my destinations from here. So I don't care about them anymore. So let me just remove them and yeah, leave it like this. So let's rerun our gateway once again. And let's see what is going to happen now. So when we reach the aggregator, let's see. At first, per each unique request, we are generating some kind of identifier. We are adding this to the headers, request headers object. And then let's see, there is the 21B. And now we are hitting our aggregator. And let's take a look. We have this request ID with the same value. And we are sending the response back. And if I make another request, of course, the transformation will happen once again with a distinct unique ID, and the same request header is being passed to this microservice. So looks like a very simple stuff, but actually, as I already mentioned, quite powerful, right? Things like unique IDs, request correlation, transaction IDs, whatever you call them, are actually very crucial part later on when it comes to things like centralized logging, monitoring, or tracing. So that's it when it comes to the YARP. A lot of good stuff here that you can find, and this set of features is actually being extended over time. So I remember quite some time ago, over a year ago, when I started using the YARP in one of the very first versions, there were maybe just a few articles there. Now there is like 20 articles, so a lot of stock here. So I really encourage you to check this out. Okay, so that's it for the episode. Hopefully you enjoyed building your custom API gateway as much as I did. As you can see, this is really, really simple when you think about adding such a gateway into your own solution. Given that, for example, we are going to use YARP, and with Ocelot, it was also very simple, but I think with YARP it's even simpler. You simply install package, the official YARP package, you just call some extension method on top of your IOC container extensions, load the configuration, and with just some basic reverse proxy in mind, you can have your API gateway fully functioning, and then you just add some additional configuration here and there, and you might set up some load balancing, request transformation, and many other great features. So, as usual, thanks for watching and see you in the next episode.